In addition to the computer models that meteorologists use for general weather forecasting, there are also specialized models for certain phenomena, such as air quality and the vibrancy of sunsets. And this time of year, if you're headed to the beach, another specialized model is very relevant, one for rip currents. Sometimes called rip tides or undertow, rip currents are the greatest hazard to swimmers on beaches where waves break. They are narrow, fast-moving channels of water that start near the beach and move away from shore. A typical rip current is 50 to 100 feet wide and can extend 100 yards or more offshore, with water moving at times faster than the best Olympic swimmer. A rip current doesn't pull you under, it just pulls you away from shore. According to a recent study that used 20 years of data from the U.S. Life-Saving Association, rip currents are the main cause of 75% of water rescues on East Coast beaches and an estimated 100 deaths per year in the U.S., many on beaches without lifeguards. If you're caught in a rip current, you should not try to swim against it. Instead, as the National Weather Service says, to break the grip of the rip, swim parallel to shore until you're out of the rip current, then turn to follow the breaking waves back to the beach. Rip currents are usually strongest near low tide when breaking waves pile water up between the shore and an offshore sandbar. When a gap develops in the sandbar, a rip current forms as water rushes away from shore through the opening. Rip currents are often hard to see from right on the beach. They're easier to identify from an elevated spot such as a lifeguard tower or dunes overlooking the beach. Visually, rip currents appear as areas where waves aren't breaking and foam, seaweed, or discolored water often concentrates and moves offshore. Rip currents can form any time regardless of the weather. You just need breaking waves, and generally 2 to 3 foot waves are enough. But when wave activity increases, as would happen with a storm nearby, the rip current hazard multiplies. Even a distant hurricane can cause problems. In late September 2019, the center of powerful Hurricane Lorenzo never got closer than 2,000 miles from the U.S., but the swells it generated contributed to large waves that led to 6 rip current-related fatalities on the East Coast. Of course, an accurate forecast of the likelihood of rip currents might prevent more people from putting themselves in harm's way in the first place, and in 2021, NOAA released the first ever operational probabilistic rip current guidance in the United States, the brainchild of Dr. Greg Dusek, who worked on the problem for more than a decade. The model takes output from wave and water level models and produces hourly forecasts of the probability of rip currents. Here's an example focusing on the South Jersey shore that takes us through this coming weekend. The blue line is the probability of rip currents. Notice it stays below 50%, which is the red line and considered high risk, until Saturday, and then stays above 50% pretty much most of the time through the day on Sunday. Stay tuned. We'll let you know if the weekend will feature any beach weather in the extended forecast next.